This video is the beginning of scientific notation. What we're going to talk about today is what is scientific notation, and then we're going to go into positive powers and how you handle positive powers in scientific notation. So if you go to this first flap, it's a scientific notation, and what it is it's a method of writing very large or very small numbers by using powers of 10. Okay, so there's going to be three parts of this. So you have the number, and then you have times 10, and then you're going to have an exponent. This exponent is an integer. So it can be a positive or a negative number, or it can be 0, but it cannot be a fraction. And then this number has to be between the numbers of 1 and 10. It can include 1, but it cannot include 10. So whenever you're looking at the different numbers, you need to make sure that the number that you're looking at is between 1 and 10. Okay? And that's what's going to go in this box. So here, it says to determine whether the following numbers are written in scientific notation. So what we're going to do is we're just going to look and see if the numeric portion is in between 1 and 10. Right here we have 3.12. Is that number between 1 and 10? Yes, it is. Okay, this one, 0.56. Is that between 1 and 10? Well, 0.56 is less than 1, so no, it is not. At a later date, we're going to come back and fix them. This one, 91.2. Is that between 1 and 10? No. 7.6. Is that between 1 and 10? Yes, it is. Okay. 0.13. Smaller than 1, so no, it is not between 1 and 10. And then we have 83.4. Also not in between 1 and 10. 83 is too big. Okay, so we're going to go on to working with positive powers. And like I said, we're going to come back and fix this at a later date. So turn the page to positive powers. And what positive powers is it's a method used to represent large numbers. For example, the distance between Earth and the sun. So here we're talking about very large numbers. So right here, we're going to rewrite each one of these into scientific notation. So the format, again, is going to be a number between 1 and 10 times 10 to an integer. And in this case, we're doing positive powers, so it's going to be a positive number in the exponent. So what we're going to do first is we're going to see where the decimal naturally occurs. So whenever you have just a whole number, the decimal is at the end. We want the decimal to be in between over here because we want this number to be in between 1 and 10. So what number dealing with 75 is in between 1 and 10? Well, 7.5. So now we're going to figure out how many places we need to move this decimal. So we're going to go 1, 2, 3, 4, 5, 6, 7. So the number is 7.5 times 10, and then the exponent is going to be 7. Okay, we're going to try it again. So right here, the natural decimal is at the end. In order to make this number between 1 and 10, we're going to put the decimal right here where the comma is. So the number that we have is 4.56. We're going to multiply it times 10, but we have to figure out what the exponent is. So right here, we're going to go over 1, 2, 3. So we just write a 3 as the exponent for that one. Okay. Now, same situation. We're going to do this one. We start with the decimal at the end. If we want the number to be between 1 and 10, we're going to put the decimal here because we get 8.1. And then we're going to move it. So first I'm going to write, so I'll put 8.19 times 10. And then I have to figure out how many times we're moving it. So we're going to move it 1, 2, 3, 4, 5, 6 times. So you just write a 6. The last problem here, same situation, put the decimal at the end. To make this number in between 1 and 10, we have to put the decimal right here. So we'll have 1.083. Remember that it can include 1, but this is still bigger than 1. So we have 1.083 times 10, and we have to figure out how many decimal places over we're moving. So just count 1, 2, 3, 4, 5, 6, 7, 8, 9. And write 9 there. Okay, so that is how we rewrite in scientific notation. Now we're doing the opposite. We have numbers that are in scientific notation, and we want to write them in standard form. I'm going to zoom out just a little bit here. We want to write these in standard form. So right here, I'm going to write the number 7.8, and then we need to move the decimal 9 times. So I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the new decimal will be there or at the end. So now I'm going to put a 0 into each one of these little humps. So we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so now whenever we rewrite this, we want to put the commas in and leave out the little divots. So I'm going to write 7, 8, 0. 1, 2, 3, 4, 5, 6, 7. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I'm going to count this direction and put a comma every 3 digits. So that would be my answer. The next one, and now you can see why we would write it this way. This is way simpler than writing all these zeros and keeping track. So this one, we need to move it over 7 places. So we have 1.009. We're going to move it over 7 places. 1, 2, 3, 4, 5, 6, 7. All right, so now I'm going to rewrite the number 1009 0000. Now I'm going to count the other way. Every 3 numbers I'm going to put a comma. And then I have 10,090,000. Again, a really big number that's difficult to deal with. Okay. Okay, 2 more examples. So we have 3.91. We're going to move it 5 places. So 1, 2, 3, 4, 5. I'm just going to put a 0 in each one of those little spots. And now I'm going to rewrite it. 391000. Now I count backwards by 3s. 1, 2, 3. Put my comma in. So this is 391,000. All right, the last one is 11. So we're going to have a whole lot of places here. So I'm going to start with 4.561. Now we're going to count 11 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to write a 0 for all of those. So I had 8 zeros. So now I'm going to rewrite it. 4, 5, 6, 1, and then 8 zeros. Now I'm going to go backwards by 3s and put in the commas. All right, and there's our answer. 456,100,000,000. All right, so that is all you have to do when you're dealing with positive powers in scientific notation.